Here in problem number 77, we're given some conditions that are met, and we're asked to see which statement must be true according to the intermediate value theorem. So let's remember a couple of things here. They tell us that f is continuous on the interval from 2 to 4, and that's important. If f is continuous, then the intermediate value theorem applies. Now, what the intermediate value theorem tells us, remember, is that if a function is continuous and the function contains 2 points, then the function must contain every x value and at some point every y value between those points. So for example, we could have a graph that looks like this, that goes through 210 and 420. That's a continuous function. Or we could have a graph that looks like this. That's a continuous function. We don't know. So let's see a couple of things here. In statement A, they say f of x equals 13 has at least one solution on the open interval between 2 and 4. So that means if f of x is going from 10 to 20 on the interval from 2 to 4, that's somewhere in between f of x is going to equal 13. I'm going to say that this is true, but we'll check the other statements just to make sure. Statement B says f of 3 equals 15. Well, that's not necessarily true. Our function is continuous, but it doesn't mean that our function increases at a constant rate. So we don't necessarily have to have the middle x value give us the middle y value here of the function. You can see here's an example where f of 3 is clearly far bigger than 15. So B is out. There's a counterexample for statement B. Statement C says f attains a relative maximum on the open interval from 2 to 4. That's not necessarily true, because here's an example where there is no relative maximum. Now, they're not talking absolute value maximum, including endpoints as considerations. They're talking about relative maximum on the open interval. So here's an example that proves part C is possibly false. Part D, f prime of x equals 5 has at least one solution on the open interval. Okay, now here they're saying that your average rate of change is 5. So the mean value theorem might say that the instantaneous rate of change has to be 5 somewhere on the interval. But what they don't say in the statement is that this function is differentiable everywhere. This function could have a cusp, and therefore it's possible to have slopes that never equal 5. In part E, f prime of x is greater than 0, or f prime of x is positive for all x on the open interval. Now we can draw some counterexamples there. Here's one where f prime is positive and negative, and even 0 somewhere in the interval from 2 to 4. So the answer is A. F of x must equal 13 somewhere in the interval, because 13 is between 10 and 20, and f is continuous. Hopefully this video was helpful. Thank you for watching.